Hi all. In this video, we are going to see a paper titled "Not All Tokens Are What You Need for Pre-Training." So, what this paper says about. So, we all know that success of large language models like ChatGPT is due to utilization of a billion size parameterized model and large, big, huge available data. So potentially, we know that large language model is like kind of a sequence predictions model, where it conditions upon the previous tokens to predict the next level tokens. So this prediction capability is always uh, not efficient while during train for the reason because of the poor quality in the data. So many attempts have been done to make efficient data filtering and then goes for the ChatGPT pre-training model. So, despite this kind of data filtering, still there exists room for better training for the reason because there are many noisy tokens are available which can negatively affect the pre-training process. So that's what this paper comes from. So this paper attempts how these large language models can be explored to avoid this kind of training inefficiency by examining the dynamics happening at the training time at the token level loss. So the loss function is a cumulative loss function of all the token level loss. So we are just they wanted to evaluate how this token level loss evaluate during different epochs during the training process. On that analysis, they identified nice observation that all the tokens are not uniformly contributing for the total summed up loss functions. There are certain token level loss called as easy tokens, which doesn't significantly contribute for a big loss function. So the learning process is not being contributed from their side. At the same time, there are tokens uh, distinguished as hard tokens, where that token level loss, that token gives token level loss a higher loss. So, which during the pack propagations, which gives you a effective training process. So, this by this analysis, they introduce a novel selective language modeling objective. In that, what they does is three steps, which we will come again in the figure 4. So this what they does is that it will be kind of a three levels which we are going to see it. So but before that we'll see this token level loss. What does mean by token level loss? What does mean by easy tokens? What does mean by hard tokens? So this is what language modeling, and this is going to be fed, and the previous tokens is going to be fed to identify the next level token predictions. So during that there are some different color markings. So these are the token level loss that doesn't contribute for the significant learning. So other tokens seems to be okay for a learning process or a learning dynamics. So they have proposed three steps process called row one, selective language modeling. And before that, we will see that what are the different types of token level loss. What are the categories of they categorize the token level loss into four categories. One is high loss to high loss to high loss, low loss to high loss to low loss, and low loss to low loss. Similar something like this. Maybe I have to put, yeah. So these are some of the high to high, low to high, high to low, low to low. So what they identify is most of the tokens are belongs to this category, low to low, and recently some portions are belongs to high to low. So this uh, token almost occupying a significant portion of the token level loss, and as well as they are distinguished as a easy tokens, which doesn't much contribute for the learning process. Only a few percentage of the token loss like high to high and low to high are termed as hard tokens, which contribute for the loss functions. So once they identify what so they made into this three steps process. What they do is they take as a reference model, and they prepare manually a high quality data and learn those reference model. And once that reference model is being learned using the assumed and determined high quality data, those reference output of those trained reference model again being utilized for the noisy data, and which the training loss functions are evaluated. During those training loss functions, we will see which are the high loss, low loss, and which are easy tokens and high tokens are being distinguished, and that tokens are being filtered out. Then once those tokens are being filtered out, then filtered clean data is again fed to the expected model, and that is been again fine tuned to give that language model. So this is three steps. One is fitting the data such a way that data will be efficient for the high quality data. Once data is given, that it will try to see which can be a high loss and low loss, or a easy token and hard token. Once the data is prepared, then again it fed into a proper desired language model to train those parameters in the language model. So this is what this pipeline of the selective language modeling, this paper is trying to focus upon. So hopefully we'll see some other paper in the next video, and this is one of the best paper in the NIPS 2024. Thank you.